Welcome back. We're continuing Chapter 7, talking about boiling and boiling point, which is Section 12 in Chapter 7. So boiling is a form of evaporation, where the conversion from the liquid state to the vapor state occurs within the body of the liquid through bubble formation. So when you boil something, if you have like a glass pot or a clear teapot, you can see this happening on your stove. When you boil something, you're forming bubbles of vapor of that liquid within the liquid phase, which is, I just think, super cool. So boiling occurs when the vapor pressure of the liquid reaches a greater value or equal value as the external pressure on the liquid. I know that's a lot to say at once, but what's happening is the pressure, the vapor pressure of the liquid and of the vapor phase of the liquid is greater than or equal to the pressure outside the container, the atmospheric pressure. So when enough particles in the liquid phase, right, they're kind of close to each other, sliding around. When enough particles in the liquid phase get enough kinetic energy to turn into a vapor, if they do that within the liquid, you form like a bubble of vapor, and this pressure inside this bubble, this pressure has to be higher than the pressure outside in the atmosphere. Otherwise, the bubble will just collapse and recondense into the liquid phase. So the pressure of these bubbles of the vapor phase, the vapor pressure, is greater than the pressure outside the container. And that's how you can form bubbles within the liquid, and the bubbles rise to the surface because gases are less dense than liquids. So the gas bubbles are going to rise to the surface and then evaporate off the top of the surface. So the boiling point is the temperature at which the vapor pressure of a liquid becomes equal to or greater than the external pressure. So evaporation is when the vapor pressure is less than the atmospheric pressure. So evaporation happens when vapor pressure is less than the atmospheric pressure. Bubbles can't form within the liquid. No bubbles. But molecules can still evaporate off the surface. And when the vapor pressure of the liquid is greater than or equal to the atmospheric pressure, that's when bubbles can form within the liquid. They have enough pressure built up to form within the liquid, to rise to the surface, and then evaporate off the surface. So the normal boiling point that we refer to sometimes in chemistry is the temperature at which a liquid boils under a normal pressure. And we consider normal pressure the pressure at sea level. So when we refer to the boiling points of substances, like the boiling point of water is 100 degrees Celsius, that's the normal boiling point. That's the boiling point of water at 760 millimeters of mercury, or 1 atmosphere, which is about sea level. So because boiling point depends on the atmospheric pressure, that's why we have to kind of give a clue as to what atmospheric pressure we're talking about. So normal boiling points are the boiling points that are typically listed for substances. The boiling point of a substance at sea level, 760 millimeters of mercury, or about 1 atm atmosphere. But as you can imagine, if the atmospheric pressure changes, it's going to change the boiling point, because for something to boil, the vapor pressure has to be greater than or equal to atmospheric pressure. So atmospheric pressure changes based on elevation. Like when you go up in the mountains, there's less atmospheric pressure because there's less atmosphere, less gas basically pressing down on you. So as you go up in elevation, there's less atmospheric pressure, which means it's easier for lower vapor pressure substances to boil because there's less atmospheric pressure they have to overcome to make bubbles within the liquid. So boiling points change with elevation. So boiling points are going to decrease as you increase in elevation, because at higher elevation, atmospheric pressure is reduced. And so if you have lower atmospheric pressure, it's going to take less energy for the liquid to evaporate. So evaporation is going to happen at a lower temperature. Less energy means it takes less heat, which means things can be at a lower temperature. So at lower pressure, evaporation is going to happen at a lower temperature. When evaporation happens at a lower temperature, you get more molecules into the vapor phase, exerting pressure over the liquid, which means it's going to be easier for the vapor pressure over the liquid to surpass the atmospheric pressure to allow bubble formation and boiling to happen. So if we check out this table from your textbook, it gives you some examples of how boiling point decreases with higher elevation. So in Sacramento, we're about the same elevation as New York City, just a little bit above sea level. Atmospheric pressure is about 760 millimeters of mercury, and the boiling point is about 100 degrees Celsius. As you go up in elevation, say to Leadville, Colorado, it's at 10,000 feet. That's about the highest some of the peaks in Tahoe get. You can boil water at 89 degrees Celsius. That's because the atmospheric pressure at 10,000 feet is less. So it takes less energy to get the vapor pressure of the liquid to be high enough that the vapor pressure is more than the atmospheric pressure. And so because it takes less energy to do that, you can boil water at a lower temperature. Top of Mount Everest, you can boil water at 70 degrees Celsius. And if you think about Death Valley is low in a depression. Its elevation is negative 282 feet. So you're going to have to boil water at a hotter temperature in Death Valley in order to get a rolling boil. This is why recipes have to be changed for cooking at high elevation, because some of the chemical processes used in cooking require a certain temperature. And so it's going to take more heat or maybe more time to achieve that temperature at a higher elevation. It's also why if you go backpacking and you ever boil your water when you're backpacking to disinfect it, at higher elevation, you're going to have to boil your water longer because say you're somewhere in the Sierras between 10 and 20,000 feet. Mount Whitney is the highest peak in the Sierras, is at 14,000 feet. So you're going to be hitting your boiling point between like 89 and 85 degrees Celsius, somewhere in here. So if you're boiling at, say, 85 degrees Celsius, you're going to have to boil your water longer to kill potentially pathogenic, dangerous, bacteria and, cryptosporidium and that sort of thing. Because normally if you were boiling at your house, you'd be boiling at 100 degrees, so it might only take 10 minutes to kill those bacteria. But if you're boiling at a lower temperature, it's going to take a longer amount of time to kill the bacteria because they're not getting heated up as much to break down their cells. So I obviously like backpacking. And this is something you have to take into consideration as you're at high elevation, how long you have to heat things to make them safe, how long you have to heat things to cook them properly, to make them safe to eat and to make them taste the way you want them to taste. Okay, our last section in chapter 13 is section 713. It's on intermolecular forces. We're going to bring together a lot of what we've been talking about in the second half of chapter 7 when we talk about intermolecular forces. And it's one that I really like because it explains why some liquids behave the way they behave. So I'll see you next time for that. Have a good one.